Good afternoon, everybody. Thank you for inviting us, by the way. We are very happy to share our story with Aerospike. Great product, great people. Actually, I wanted to share my presentation with Nick. I have to give him credit because his team actually, maybe I should try to get the slide going here. Oh, yes. These are our names. Nick's team actually implemented Aerospike, and I have to credit that to his team that we actually up and running. He's currently doing video interviews in the back room, and I hope he comes in time. Just give me 1 second, not that I forget something. We are actually, how did we get in touch with Aerospike? There was actually both investors, they knew each other. And one day, my investor came to me and said, hey, check out those guys. So I invited Srini back in 2015, do you remember that? And then that started the whole journey, and then we took all this time to plan out our Aerospike cluster and actually put it in production. And there was one hurdle to get the contract done, because when I joined ThreatMetrix, we were working off a standard database sharded system that had all those problems, and we had latency, problems that we called spikes. And I got in trouble for suggesting a company that has Spike in their name. But it turned out really well. How can you trust guys that have Spike in their name? We called them spikes, and we were suffering a lot with those spikes. And now I'm suggesting a company called Aerospike. But I'm glad we did, and just as a side note, by the way, also for your interest, we got acquired a couple of months ago, and we are now part of LexisNexis Risk Solution. I should mention that, because when the invitation came through, we were still ThreatMetrix. This is a famous cartoon from Peter Steiner in the New Yorker magazine, and it illustrates exactly what our problem is. If you offer a service over the internet, you have basically nothing. You have the IP address and everything what this guy types in. And they have no way of verifying this information. And exactly this is where we play. You can have like account takeover scenarios where you usually log in with your device, with your username, your password, and suddenly your username and password is being found in another device in another country. And of course, we can get this information. Another cool example is your computer was taken over by a remote access Trojan. That means you're still using your computer, your username, and your password, but it's remote controlled by somebody else. So we're also doing remote access Trojan detection and give you all this additional information to secure your online business. These are customers that we work with, and I'm not showing that to say we work with all those customers. We can touch point a customer multiple times a day with this journey. You might book a flight in the morning, and we see you at CyberSource. You might post a review on TripAdvisor, we see you there. You might then check your online balance with Citibank, and then you might go and buy something at Best Buy and Walmart. And we see all those transactions, and that's how we build up our, what we call digital identity network with those transactions. We do 130 million transactions a day. And one of the things that from the beginning of time, we wanted to have a central database where everybody calls into. So we never went on-premise instance where we only saw local traffic. Right from the day, we wanted to be a global database where every one of our customer calls into, and we can basically cross-correlate everything in real time on a global scope. One of the ways to fight fraud is not really detect fraud. One of the ways is also to recognize good customer behavior, because the more you can assign as good, the less you have to check for other anomalies. And this is a slide where that should tell you that we have quite a good coverage here. But don't be confused. If we say 95 to 100%, it does not mean that we know 95 to 100% of the population. It means if we do a transaction, in 95% to 100% of the cases, we recognize at least one of those properties that came in. So, I mean, this is our customer base. It's not like the global population. But this is a very cool way of like also detecting known customers and to a smaller your area where you have to look for fraud and anomalous behaviors. Also funny thing is countries. How many countries are there in the world? Of course, 195, but if you look at ISO country codes, it's 249. Every hour we do business with 240 countries, and I looked up which countries we do not do business with, and there are like 4 countries. One is Western Sahara. A few people live there, but no internet. The other one is, I don't know. Bouvet Island is completely inhabited, so we can't see any transactions there. So out of at least 4 of the remaining 249, it's not possible to do business. Again, a few numbers here. Now the majority of transactions are mobile. It's also quite interesting that it has taken over the 50% mark. We have around 1.4 billion accounts that we protect, and our current run rate is 3 billion transactions a month. That's right. So, and this is also a slide where I want to tell you that we are a true real-time company. We don't do pre-calculation of values. From the beginning, we wanted to have a real-time system where you can do whatever you want to do. If you want to calculate a new variable, let's say you want to calculate the number of devices associated with this email in the last week, in 2 weeks from now, you just go into our portal, define what you want to have, hit enter, and we have to calculate it in real time. So we don't have any offline processes that calculates velocities and stuff like that. We do everything what we do in real time. And it's one concept that we did from the beginning on, try to be a true real-time company that makes risk decisions in a very, very small window. And you have the flexibility to calculate every variable that you want to. And you don't need to wait 24 hours until we have crawled through our big database. You can do it right away. And that's one challenge that we have. We need to have a massive database in the background, and Aerospike is a company that allows us to do that now with an average request duration in our main data center of 35 milliseconds around, and it's very, very cool. And without Aerospike, we would not be able to do that. Then I have one slide where I just give you one example of how you do real-time decisioning. And of course, there are many other examples. This is one example which is quite easy to comprehend that came from a customer where we do every year a certain transaction. I don't want to reveal too much, but their problem was after a year, lots of people lost their password. And it was much easier to sign up with a competitor than to regain your password because you have to go through all those stupid security questions, and nobody knows that. So the challenge here is, if somebody comes back after 12 months and has lost their password, should I challenge this user? Hey, it doesn't. I should challenge this user, but I think I made a mistake here. But if you can tag 3 different properties, if you tag the user, the device, and the location in real time, and then verify that after 12 months, the same user came with the same device and the same location, and you can verify that in real time, this customer chooses not to do security question, just issue them a new password. And it was good customer recognition, and their fraud value, they didn't go up. So you have the majority of the users that lost their password just came with the same device at home, file their stuff. And that's one of the success stories that we had. You see, it's not really fraud prevention, it's just enabling business. And with this, I want to invite Nick on stage. He will talk through more of the technical details. There are stairs, right?
Hi, everyone. Seems like Matthias started without me, but that's all right. No, that's okay. I mean, Matthias has given you a general overview of ThreatMetrix, and one of the specific things that I want to talk about is our journey specifically in regards to the storage layer and obviously Aerospike. And we switched to Aerospike a couple of years ago, and when we were evaluating our storage layer, you know, we had a bunch of requirements, and they're on the slide, and they're fairly, well, I mean, depending on the size of the amount of data you have, there may or may not be exciting. But certainly big things for us was latency and specifically consistency. Because of the way we do our operations, if there's some inconsistencies in the performance, that will really hurt us. We've got multiple data centers, so we need to be able to replicate data between them. We've got a reasonable amount of raw data that we have to index and deal with. And obviously, you know, if it's easy to operate, and that's a bonus. Must have support for us. It was C++ and Java, with C++ really being the primary use case here. So if we get a little bit more specific, these are our storage requirements, and it doesn't really matter if you can't see the numbers. The trend is what's important there. And in fact, that's the graph from the last 12 months. And that's going from approximately 110 terabytes to just over 200 terabytes. That's at RF2, so half of that is real data. And you'll have to excuse me, I've got some notes on my slides, but I can't see them on the screen, so I'll just have to refer to my notes here. So one thing Matthias would have covered was, you know, 40,000 websites, 130 million transactions a day. And all of that results in a lot of data, and that's why we get this kind of trend. Obviously, our business is growing as well. Internet usage and merchants are growing. And so it's not growing linearly. That does look fairly linear, but it is actually accelerating. And that certainly is providing challenges for us, because the next thing that we care about after being able to store the data is obviously to retrieve it and make use of it in a timely fashion. And this graph is a little bit funny looking. This is also the previous 12 months. And the graph shows the IOPS. And you'll notice the big funny looking peak at the start of the year. That's the US tax season, which gives a big spike in demand. But over and above particular peaks, there is just this annual increase again. This quote that Amazon loses 1% of revenue for 100 milliseconds, I wasn't actually able to find any solid verifiable source for this. It was just reported on a bunch of blogs. But it does seem to be generally accepted that, you know, you increase cart abandonment, you lose money if your processes take too long. So don't quote me on that Amazon thing. And obviously this, you know, it's increasing year on year. And for us, having a faster performing storage layer allows us to do more. And customers always want more. Our products guys always want more. And if we can shave time off the storage layer, it allows us to do more without impacting our customers. So I want to talk a little bit about where we came from. And when we started in the mid-2000s, so 2005, I think, NoSQL really wasn't much of a thing at that point. And so we grew this incredibly janky custom solution that was based on SQLite, if you can believe that. And that's how we started our business. And after a few years of using that and growing it, and this was a sharded, clustered SQLite, we realized that we weren't, if we needed to fix the storage layer, we weren't focusing on what was important for us, which was the risk engine and the rules engine. And so at that point in time, around 2000, I think 2012, Cassandra was made public. It was a little bit after that that we started seriously investigating it. And I won't lie, that transition was incredibly painful. But the net result of it was we got off our custom solution and we got onto Cassandra. And Cassandra was beneficial for us, and it allowed us to grow to an extent. One of the issues we had when we switched to Cassandra was we went through their sizing exercise, and we thought, right, we need a 6-node cluster. We rolled it out, and it was dreadful and slow, and so we doubled it to 12 nodes. It was still dreadful and slow. We doubled that to 24 nodes, and we started seeing some of the benefit. And we kept doubling the size of our cluster until it got up to 96 nodes in a single data center, mind you. So that was when we had 2 data centers at that point in time. So we started having a really serious number of Cassandra nodes, and there's a decent amount of overhead in just managing that many machines. And so at that point, this was early 2016 by then, and we decided that it was time to look for the next thing. And I have this marketing material that I'm sure you've all seen. This is the Aerospike claim of 10x. And of course, when I first saw this, I'm generally a fairly skeptical guy. And so I saw this and I just thought, there's no way. You know, this is typical marketing material and has no basis in reality. And so we started out, well, we did some tests, and it did test pretty well. And so we thought, you know, we'll do this, and we started our move, and, you know, so, well, that's actually, I missed that. So one of the challenges we had with moving from Cassandra to Aerospike is actually getting the data out of Cassandra. And Cassandra doesn't really know what records it has. It has to go and dig through files to figure that out. There's no good way of walking the entire namespace in Cassandra. So we wrote a custom tool that would read SS table files directly off disk and inject them into Aerospike. And this allowed us to have Aerospike and Cassandra running side by side, doing double writes into both clusters, and take a backup from Cassandra and run our tool over this backup and blat the data into Aerospike. So that the migration was significantly less painful than when we went to Cassandra. And in part, you know, it's like moving house. The more often you do it, the less junk you accumulate, the easier it is. Moving to Aerospike was definitely easier. If we ever had to do it again, it should still be fairly easy. Although we are starting to use some of Aerospike's features, which is going to create a little bit of lock-in. And so this is getting back to the question of, is it really 10x? And this is a graph of our response time over 2 years. And you possibly can't read the text. It doesn't really matter. At the top left, at the slowest, that's with Cassandra. In the first little dip, that was when we added more nodes to Cassandra, and we got a little bit of a performance gain. So that was from approximately 120 milliseconds to about 100 milliseconds. And then there's the long, slow decline, or it's not really a decline, but the decline in times as we're moving more and more functionality over to Aerospike. And in the bottom right corner of the graph, we're at about 30 milliseconds. So that's pretty impressive. And we're doing it with less hardware. We went from 96 nodes to 28 nodes. Went from 100 milliseconds to 30 milliseconds. So I don't know if that's really 10x, but it's pretty good. There is a little bit of a caveat, though, and it's not really an apple-to-apples comparison because During that time, we about doubled the amount of data we had. We increased the amount of traffic we were dealing with. But the hardware also got a little bit faster. We put more RAM in those nodes. The SSDs are a little bit faster. So yeah, I wouldn't necessarily claim 10x, but the performance improvement was seriously impressive. So I'm not sure what happened with that slide, but anyway, along the way, there was a couple of benefits that we came across that I certainly wasn't expecting. The first one is the SSD write endurance. So just how much extra data is written to the drive, which, as you know, with SSDs, they wear out. With Cassandra, there's a lot of extra overhead because it's compacting files and doing a whole bunch of extra writes. And our daily writes, drive writes per day, dropped down to about a quarter with Aerospike. And that wasn't something we were aiming for. It wasn't even something I was looking for. I was putting together some facts for this presentation, and I discovered that. I thought, that's pretty cool. The second thing is Aerospike support. Maher and his team have been really fantastic. And I'll give you a little anecdote. Well, I mean, I did earlier with the Cassandra sizing. Our capacity planning for Cassandra was way off. The cluster that we spec'd out 2 years ago, or 18 months ago, no, 2 years ago, with the Aerospike team is the same cluster we've got today. And okay, now we're looking at making it bigger, and I'll talk about that in a minute. But it's lasted us the last 18 months quite comfortably, both in terms of storage and performance. So that's been fantastic. The last one is user-defined functions. This is functionality that we are hoping to use quite a bit more in the future because it allows pushing the synchronization of our application down to the storage layer, which is what you would do with a traditional database. And for us, that's more offloading of responsibility to some other engineering team. So we don't have to do it. But ultimately, that's the right way to do it. You know, you don't want to reinvent the wheel all the time. So UDFs we are using in a small number of cases today, but we are hoping to use them quite a bit more in the future. So now that I've gone through the pain of the, moving to a new storage layer and all the various teething pains that go on with it, at the end of the day, I'm very happy with Aerospike. Software is always trade-offs. There's trade-offs between RAM usage and performance, or disk size, or cost. And having excellent software is about making the right trade-offs. And I certainly feel that Aerospike has done that. I won't say that it's without its problems. All software has some problems. And as I said, it's a matter of trade-offs. And for us, the trade-offs are well worth it to get the excellent performance that we get. And I mean, you guys saw the graph. It's definitely going in the right direction. And over that 2-year time, what I didn't mention was that we also added a whole bunch of extra features. And in fact, when we first rolled out our cluster, our main constraint was the amount of RAM in the boxes because we had so many records. We had, 80 billion records or something. It's a large number. And that was our initial constraint. But once we realized we had all this extra disk space that we could make use of without really any performance hit, obviously we changed our product and we took advantage of that. And now we're starting to run out of disk space, but it's always one thing or another. So I thought I would just run through what our cluster looks like today and what our next 12 months looks like. So right now, 28 nodes. This is per data center, so this is not globally. 450 terabytes of disk and 20 terabytes of RAM. So individual nodes are not small, they're not cheap, but dealing with 28 nodes is a whole lot easier than 96. Unfortunately, because we are now getting more records, using more space, we do need to add nodes, and by the end of the year, we should be at 48 nodes with 1.3 petabytes of flash storage in one data center. We now have 3 data centers. So buying SSDs becomes a bit of an exercise. But it allows us to do what we do very quickly and to grow our business. And I think Matthias mentioned the acquisition by LexisNexis. And that was in part because we are world-class at what we do. I don't know how much detail, I was doing a video interview, but I don't know how much detail Matthias went into with the structure of our data center or our application. We have a load balancer, obviously, that takes requests and splits it between numerous API servers. The API servers do all the boring input validation type stuff before passing the requests onto our application layer. And our application layer will make quite a large number of requests actually to the storage layer. It can be, it's probably 30-ish on average, but that can easily increase to 100 or more depending on the exact query type. And obviously when you're making 100 different database queries, your response time is gated by the slowest query. And so we have definitely felt the pain of having SSD hardware that is not completely consistent with its latencies. And so certainly I was very keen on the Intel presentation earlier. That seems like very exciting developments that we will certainly be looking into.
How many terabytes per node? I mean, the biggest opt-in SSD is 1.5 terabytes.
Today. So I mean, we have today 18 1.8 terabyte drives per node. So you're right. Today it's not big enough, but I'm assuming that's going to improve. So I think that's. Oh, this is the read latency. And so you can see it's generally very good, but there is little spikes, and those spikes do hurt us. But those spikes are not from the software, at least to my knowledge, they're from the actual hardware. All right, so I'm done, but we would like to take some questions. Matthias, do you want to?
When you say 30 milliseconds, is that just the Aerospike time that you're measuring?
Oh, not at all. Not at all. So the question was, is the 30 milliseconds just the Aerospike time? And that's the end-to-end time. So for our customers, obviously, there's network latency, but we can't measure their network latency. But other than that, that's the 30 milliseconds they see from end to end for all our various applications and services that goes through.
So you have a user agent, so you have a new user agent in the client telling you it's 30 milliseconds? Is that where it's measured?
So on our API server, we see the incoming, and we see the outgoing, and we measure the times.
There's a question here.
Yeah, so from a hardware perspective, let's say from a storage device perspective, would it help if you get something like 5 nines, 6 nines, or 7 nines of consistency on the latency?
Absolutely.
Is that what you're looking for?
Yeah, definitely.
I see. And what would be your let's say a number? Is it 5 nines or 7 9 or 8 9? Have you looked into that?
More nines, the better, really.
More nines.
I mean, our use case is a little bit odd in that our cluster peak would probably only be about 250,000 IOPS, which from a throughput perspective, it's not enormous. But it's the latency and the consistency of those requests that is really important.
Okay, so since you mentioned about Optane and you said that that's really interesting, the money is not a bar.
Of course, money comes into it.
Well, as you might know, the Optane is a costly device.
I believe it's approximately twice the price.
Yeah, probably around that, yeah. So, okay.
I mean, if it comes down to buying more expensive storage hardware or adding more nodes, you know, the costs need to be evaluated either way. The nodes aren't cheap.
Right, so let's suppose if somebody can offer you you know, a regular SSD-based solution, but you know, it looks like that performance doesn't, like in terms of IOPS or number of accesses is less important. What is more important is the consistency part for you.
Correct.
And if you all, you know, if somebody says, okay, well, you know what, here's a device that is really very consistent, and more nines the better, obviously, that would be something that would be interesting to you,
It
right?
definitely would be. I mean, it's not that performance is not important, obviously it is, but it's more about the latency.
Sure, and consistency.
And consistency, for sure.
All right, thank you.
There's some more questions here.
I was just going to ask, Nick, how big are your records on average?
That's a good question. They're typically between probably 10 and 100 kilobytes.
Okay, so pretty big by
The average
the usual.
actually for the entities is 2.5K over all the records.
Yeah, it depends which record types you're talking about.
I mean, they vary quite a bit, but I mean, if I do my calculations on the entities, it's 2.5K average, which a large number of very, very small records. So we have
Right.
also quite a few big records up until, I think, a megabyte, right?
Correct.
Okay.
In your migration from Cassandra to Aerospike, were there any kind of schema changes that you need to make, or did you basically forklift the schema over? And then as you were moving into Aerospike, how did kind of tuning it and like configuring it to perform optimally? Like, was there a lot of work there? Factory defaults?
If you're planning on switching to Aerospike, I definitely advise you to read the Aerospike limitations page. Because there is some little things that we had to deal with. One of them that springs to mind is the bin names need to be less than 14 characters, I think. And this is not a problem, but certainly we hit that and went, oh, okay, now we have to rename things a little bit. As far as tuning is concerned, we have worked very closely with Aerospike support, and we've had a whole lot less issues tuning Aerospike than we ever did with Cassandra.
So I think you kept talking about consistency of performance. Cassandra, as you might know, has a server-side JVM issue. It's based on Java, so there's a lot of consistency, performance consistency issues come from the server side, potentially not from the client side. How much do you think that played a role in your decision?
So certainly using Cassandra scarred us a little bit, and we definitely wanted something that would not suffer the same problems we'd had with Cassandra. We ended up building a whole bunch of extra software on top of Cassandra to try and get the level of consistency and reliability that we needed out of it. And I mean, that worked mostly. But it's a whole lot nicer if you can let someone else worry about those kind of things. No? Looks like about it. All right. Thank you.
Well, thanks, guys. Thank you.